with interest, here we're starting with an initial loan amount of $100,000. So that P of 0, that stands for the principal at time 0. I write that here. P of 0 is $100,000. Interest rate is charged at a rate of 5% per year, and payments are made at the constant and continuous rate of $m per year. And then P of t obeys the differential equation with the initial condition P of 0 equals P0, or 100,000. What value should m have if the loan is paid off at the end of 20 years? So if it's paid off at the end of 20 years, we want the principal after 20 years to be equal to 0. Now let's see what's happening to the rate of change of principal with respect to time, dp dt. Every year the interest rate is adding 5% on based upon the amount of principal at the beginning of the year. So I'm going to add on 0.05 times P each year. But then every year payments are being made at $m per year. That's going to be subtracted off. So your principal is increasing by 5% and it's decreasing by $m. Now, to find the value for m, we can't really do it with this derivative, but we could get rid of the derivative by we can't integrate both sides as is because we'd be integrating with respect to t to get rid of that dt, and here p is a function of t. Integrating both sides won't work, but this equation is one that's called separable, and to be separable it means that we could write the equation so that all of terms of one variable are on one side and all terms of another variable are on the other side. Here our variables are p and t. So I'm going to start by multiplying the equation on both sides by dt. That'll get rid of my dt from the denominator and put it up as a differential. Then I want my p terms on the left side of the equation, and I want my t terms on the right side. Here inside the parentheses, because I have the p in there, I want to divide by 0.05 p minus m so that my p terms come on this left side of the equation. And that's going to give me 1 over 0.05 p minus m. It's all in the denominator. dp is equal to 1. These will cancel out to give me 1 dt. And now I can integrate. Now on the left side, our next step is to do this integration. And to do the integration on the left side of the equation, we want to use the fact that when you integrate, bring this up, that when you integrate 1 over u with respect to u, you get a natural log. You get natural log of u plus c. So in this case, on the left side of the equation, we want to let u, whoops, equal the denominator, 0.05p minus m, so that du becomes the derivative of 0.05p is going to be 0.05, and the derivative of negative m is going to be 0 because m is considered a constant, dp. Okay, so I need to get a 0.05 dp on this left side of the equation. Let me change my ink color for a second. I can put the 0.05 in the numerator. That's times 0.05, so that I get the 0.05 dp, but then I have to divide it off in front here, 0.05, so that this left side becomes 1 over 0.05 times the integral 1 over u, and the 0.05 dp is my du. On the right side of the equation, we're just integrating 1 with respect to t, and that'll give us a t plus a constant of integration. So back to the left side, when you integrate this 1 over u, you get natural log of u, and now in place of the u, I'm going to put my 0.05p minus m. And then you get plus a constant of integration, but because I have a constant of integration already on the right side, those kind of incorporate together. We only need one constant of integration. And I get this equation, which gives me the solution to the equation that I'm looking for. However, I want to use the fact that p of 0 is 100,000 and p of 20 equals 0 in order to solve for my constant c, and in order to solve for m, which is really what the value I want. Okay, so let's start by solving for c. I'm going to use the fact that p of 0 is 100,000. P of 0 is 100,000 says that when t is 0, p is 100,000. And I'm going to draw a line here to separate what I've done already. Then substituting these values into this last equation that I have, I'm going to get 1 over 0.05 natural log 0.05 times p, 100,000, minus m is equal to t, that's 0, plus c. So on the right side I have c, which tells me that the left side of the equation is the value for c. I'll simplify that just a little bit to get 1 over 0.05 times natural log of 0.05 times 100,000 is 5,000, gives me 5,000 minus m equals c. So I'm going to put this value for c back into my equation so that my equation becomes 1 over 0.05 natural log 0.05 p minus m equals t plus c, and this is where my c goes, 1 over 0.05 natural log 5,000 minus m, right there. Now, once you get this equation, it might be more efficient to get these natural logs together and to make the work just a little bit easier. We actually don't have to solve for p to find the equation because it's not asking us to. What we want is we want the value for m. But if we have one natural log to work with rather than two, it might make the work just a little bit easier. So let me bring this right term over, the 1 over 0.05 natural log of 5,000 minus m, over to the left side of the equation. And I'll do that after getting rid of this coefficient. So let's first take this entire equation and multiply by 0.05 so that we have natural log of 0.05 p minus m equals 0.05 t plus natural log 5,000 minus m. And then let me bring this natural log term over to the left side of the equation so that I have natural log of 0.05 p minus m minus natural log 5,000 minus m equals 0.05 t. And there's a rule for combining natural logs that says that if you have the difference of two natural logs, natural log of a minus natural log of b, you can combine these two terms into a single natural log as the natural log of a divided by b. I'm going to use that to combine my two natural logs on the left side of the equation so that my left side becomes natural log of 0.05 p minus m over 5,000 minus m equals 0.05 t. And because I'm solving for m and because m is inside the natural log, I'm going to get rid of this natural log by using yet another rule that says that if you have natural log of a equals b, you could raise both sides of the equation write both sides of the equation as an exponential function, e raised to that power. And this e and the natural log cancel each other out to give you just a. You get a equals e to the b power. So on my last equation, if I write both sides as an exponential, e raised to the natural log power and e raised to this 0.05 t, on the left side my e and my natural log cancel out to give me 0.05 p minus m over 5,000 minus m equals e to the 0.05 t. Okay, now let me substitute in so I can solve for m. Here I want to substitute in the fact that p of 20 is equal to 0. That says that when t is 20, p is 0. And substituting in is going to give me the equation. See, my p is 0, so I get 0.05 times 0 minus m over 5,000 minus m is equal to e to the 0.05 times, here t is 20. 0.05 times 20, see, 5 times 20 is 100, you have 2 decimal places. This gives you just a 1. 0.05 times 20 is 1. So on the right side I just have e. And on the left side this term drops out. So I'm left with negative m over 5,000 minus m is equal to e. Here I need to multiply, let me take cross products. I'm going to write this as e over 1. And then I'm going to treat this as a proportion and take cross products. When I take cross products, it gives me negative m times 1. That's negative m is equal to, my other cross product is e times 5,000 minus m. It's going to give me 5,000 e minus m times e. I want to get my m terms together, so I'm going to bring this minus me over to the left side of the equation. That'll make it positive. And I'm going to be able to factor out an m. And then divide both sides by e minus 1. And here I get my value for m. I'll write that here. If you work that out on your calculator, 5,000 e divided by e minus 1, oops, you get approximately 7909.88. That's a 7909.88. And so if you pay 7909.88 per year for 20 years, and initially you've borrowed $100,000 at 5% annual interest, then your loan will be paid off in the 20 years.